Good day. We are looking at the Aromatics PowerPoint, and there's something called a benzene ring. It will look like cyclohexane, but it has very different properties. So you have to be able to look at a structural diagram and determine that it's aromatic, and you have to be able to name some simpler aromatic compounds and be able to draw structures. We're not going to get too crazy about them. And you can see the page numbers in the text. Well, this is one way of representing benzene. And we look at this and we see, oh, we have alternating double and single bonds. And you can see it's going to be C6H6. So if it's just like that, it's called a benzene ring. We just call it benzene. It turns out to be very stable. Stable, of course, means non-reactive. It happens to be a resonance structure. So although we've shown it as alternating double and single bonds, all these bonds between the carbon are the same. So essentially it'd be like a 1/2 strength bond. And it turns out there are different ways of representing benzene. You sort of have to get used to it. Well, all these carbons are identical, and the electrons involved in these bonds are said to be delocalized. They don't really belong to any one carbon atom. And so many complex organic compounds will involve a benzene ring, and often we'll find them in assorted drugs and other materials. And eventually we'll go to a site that looks at these kind of things. So, because we have this structure, this resonance structure, it is a very flat molecule. It happens to be very flat, so therefore planar. And this is because we essentially have this 4 bonds, but it's an AX3 kind of structure. When the benzene is the main chain, so we have some simple branches sticking out of it, then benzene is the name will stick on the right, and then we put the branches in front of it. But sometimes if we put a benzene ring onto a bigger carbon chain, if it's easier to name that way, then we treat the benzene as a branch, and it becomes called phenyl. And with a bit of practice, you get to figure out when to call it benzene, when to call it phenyl. So let's take a look. These are different ways. This would be representing to a molecular structure. This might be how we draw it. Notice here it doesn't show double and the double and single bonds alternate. Just put a ring around, and that ring represents those delocalized electrons. Well, in this case, we see we have methyl on benzene. So this is methylbenzene. We don't have to say one methylbenzene because we've given enough information. There's only one methyl. It could be on any of those carbon atoms. So there are 2 IUPAC names we can get away with. There's our methylbenzene. But a lot of times chemists like to cut down on a few letters, see a smaller hockey rink. And so this is called toluene as well. Now, you'll get tired of these. This is much better. What this is showing is a benzene ring. Those white representations are hydrogen atoms, and the greens represent 2 chlorines. You might remember this from grade 8. This is called 1,4 dichlorobenzene. So if this is carbon 1, we go 2, 3, 4. They're on opposite sides, so that's why it's 1,4 dichlorobenzene. And way back when, we called it para-dichlorobenzene, and those were the things in urinal pucks that you might have checked out in grade 8. So, we got lots to throw at you here. Para-dichlorobenzene, so para is when they're opposite each other, and in fact you can get away with just putting a little p in front, going p-dichlorobenzene. If they were next to each other, that would be ortho-dichlorobenzene. And if it was, let's say the chlorine's here and the chlorine was here, there was a hydrogen in between, that would be meta, so the middle. So we have ortho, meta, and para. Ortho, the chlorines would be next to each other. Meta, there's a hydrogen in between. And para, they're on opposite sides of the benzene ring. Here's another example. They've given you the name already, and they're saying, you know what, this one's easier to name if we treat the benzene like a branch. And so what they've said is, hey, let's make this our longest sausage. So that's why it's propane. And on the second carbon, we have a phenyl. This is the phenyl. So that's why it's 2-phenyl propane. And that was kind of weird. Now we're getting really bizarre. So here's our benzene, but we have this chain, and chemists are really get lazy. We don't want you doing this. It's just so you run into it. I won't ask you this on a test or anything. But every corner and end represents a carbon. So we had 1, 2, 3, 4, 5. So that's why it's pentane. And we go 1, 2. On the second carbon, we had the benzene, so it's 2-phenyl pentane. Crazy, looked like a virus. This one's, if you have studied the Road Runner and Wile E. Coyote, you will know what this is. This one is going to be something called a toluene, CH3, or methylbenzene, so it's a toluene. And these are nitros. And if you remember from an earlier video, nitros ratchet up the energy of the compound, and now we say, whoa, dynamite. And the official name is going to be trinitrotoluene. Where is that name? There it is. Known as TNT, not the AC/DC song from way back when. So nitro, nitro, nitro. There's our trinitro. You can see they're lazy. They didn't put addresses in. And the toluene is because we had the benzene with the methyl. That's about as exotic as we get. How about these? Those look pretty easy. Well, I kind of lied. That's way more exotic than what we're going to worry about in Chemistry 11. So that's it for aromatics in this PowerPoint.